Okay, so here we're going to be talking in section 9.2 about a two population means with known standard deviation. And here are some of the equations that kind of go with it if you are working stuff out by hand. If you're doing things on a calculator, then this would be a two-sample z-test. And we'll come back and touch on some of these in a bit. But let's go ahead and look at a problem. And if you want, you could go ahead and pause it and read through it. Okay. And so one of the key things you want to figure out first is, are we talking means or are we talking proportions? And then is the population standard deviation given? And try to figure out which test we're going to use here. And then we could proceed with kind of our four-step hypothesis process. So, okay. So the null and alternative hypothesis, so the HO and HA, so the null and the alternative here. And so this one's a bit of a giveaway that we know we're talking about means because it's kind of given there. Right here is what we're trying to identify as our claim. So the claim is saying that the wax 1 is more effective than wax 2. Okay. That means it lasts longer. So for this one, we know we're talking about means, and we're comparing two of them. So we're going to use mu1 and then mu2. And then our claim is saying that it lasts longer here. So we know that's going to be greater than. And then it's a good idea to just write the claim as soon as you get that there. So by default, we're going to go ahead and put equals. Okay. And so now let's look at our second step. And we're going to want to get our stats and our data. And this one's a bit easier because we do have a table set up. We don't have to kind of read through a problem. But we're going to want to get our mean for our first group, the standard deviation or the population standard deviation, and then the sample size. And we're going to want to do the same thing for the second group as well. Okay. And again, we know we're doing sigma because it says here population. So it's given to us there. So the mean is 3, standard deviation is 0.33, and then our sample size is 20. And this one, because it says that it's 20 floors are randomly assigned for each. So that means there's 20 in each group here. So for the second group, we get 29, 0.3, 6, and then 20 here. Okay. And so a slight difference between the two sample and one sample is we are looking at the difference between these. So if we subtract these, we're looking at 0.10. So that's the difference between these two here, because we're comparing them to one another. And we're trying to find out an estimate for the population or the difference in the population means. So these guys were always setting equal to 0. So for example, if we're trying to see how much money we have, if I have $20 in my wallet and you have $20, if we take the difference between that, it's going to be 0. So that means if the difference is 0, that means that we have equal amount or close enough. That's really the key thing we're trying to figure out. Or are we close enough to 0 where it is, roughly about the same? So we're looking at difference here in these population means here. And then we also want to probably get our population standard deviation for two samples here. And this is from the formulas that are given in the front here. And so if we just plug this in, and we're going to take the square root of all of this here, kind of a plug and chug, we're going to get 0.10921. So that's the standard deviation for both of these together here. So if we want to write what the distribution is, the distribution of the difference here, it's a normal. We're always going to have 0 there for the mean because we're talking about the difference in means. And then here we're going to talk about the joint standard deviation, so 0.1092. If you're using the calculator, really the notation you want to know is that we're using a two-sample z-test. And you're probably going to just use some of these raw data or some of these values that are given over here. Okay, so step 3, we're going to go ahead and do our calculations in our graph. And again, on that horizontal axis, we're looking at the difference between these, or we could also look at z-scores. And if we're looking at the difference, it's going to be 0 in the center because that's technically your mu1 minus your mu2, right? We're looking right at 0. That 0 is the value we always compare things if they're the same. If the difference is 0, we assume that they're going to be the same. And this is going to be right-tailed because it's greater than. So somewhere over here, that's going to be my critical region. And that's going to be my alpha, which is 0.05. And that corresponds to a z critical value, or what we're calling your z alpha. So this critical value is our line in the sand, right about here, right? Is this difference of 0.10 close enough to 0 where we say, yeah, it's about the same, or is it beyond that line over here in this region where it's far enough where we say, yeah, there is a big enough difference for that? And that's kind of what we're trying to figure out here. So z critical value and alpha go together, our z test statistic, and then our p values here. And we're just going to go ahead and plug these into the calculator here. We'll leave that right about there. Okay. So we're going to use a 2sampleZtest, and at the end I'll talk a little bit about how to working this out by hand. And we're just going to plug in those values. And then if we run it, we're going to end up with these values here. And so that z corresponds to the test statistic, and that p corresponds to the p value. Okay, so I'm getting these straight from the calculator, so 0.92 and then 0.1800, and we had to round in that case. And for our critical value, this is going to be an inverse norm, area to the left, which is going to be 0.95, and then 0.1 for your mean and standard deviation, if we're talking a normal standard there. And this gives us approximately 1.64. So that's an inverse norm. And that's going to go with our alpha of 0.05. So then the question is, where exactly does that test statistic fall, where 0.92 falls at? And we could see that it's to the left of that critical value. So it's always easier to compare our z-scores here, but we could also do it by comparing the areas. Since the p-value is larger, it's going to have more area, and alpha, that critical region, is going to be contained within there. So right up in here, and that's going to end up being your p-value. All right, so step 4, our discussion and conclusion, and we see our p-value is larger than alpha, so we do not reject the null, which means we reject the alternative. And since our alternative is the claim, we're going to also say we reject that. Okay. Again, if you fall your test statistic within the critical region, those are the set of values that we end up having to reject the null. So in this case, do not reject. And so for the alternative, we said we are going to then reject that and reject the claim. So we would say there is not sufficient evidence to support the claim here. And I'm allowed to use support because the alternative is my claim. Support the claim that wax 1 is more effective than wax 2. Okay. And so that concludes our 4-step process there. I do want to go back here and talk about some of these calculations by hand, and specifically how to get that test statistic of 0.92. Here we go. So when we talked about the distribution here, we see that it was 0.1092, and we calculated that on the last page there. And if we're doing stuff by hand, this is why they ask us to do this, because it makes it a lot easier to get some of these computations done. If we want to get our test statistic, we're going to do our difference in our sample means, which we've already calculated, minus the difference in the population means, which is always 0, divided by the standard deviation of both of them together, which we already calculated as 0.1092. So this just gives us 0.1 over 0.1092. And again, these calculations were pretty much all done on the last page. So we have them at hand here. And this gives us about 9158, and to 2 decimals, it's about 0.92, which is the test statistic. Let me go ahead and correct that right there, which is going to be the test statistic. There we go. Okay. And that is what we got right here. So 0.92. And once you have that value, you could use your tables to go ahead and get the p-value.